Good day, viewers all over the world. We want to consider series expansion of functions. Series expansion of functions. Of course, if we want to consider series expansion of functions, we are starting with what is called the Taylor series. So a general method for expanding a function in a power series in X, and in X minus A, in a power series in X, and in X minus A. These are two different values. A general method for expanding a function in a power series in X and in X minus A is given below. That is, we look at what we have on the board. In case of Taylor series, assuming that a given function can be represented by a power series in X minus A. So under Taylor series, we have that power series series in X minus A. That series is necessarily of the form Taylor series. That series is necessarily of this form, which is Taylor series. Then this is the expression for Taylor series. That is when you have f of x, it will be expressed as f of a plus f prime of a over 1 factorial x minus a, f prime prime of a all over 2 factorial x minus a, plus this is the second to the last, f n minus 1 all over n minus 1 factorial x minus a into bracket n minus 1, then plus Rn of x. This is the remainder. This will represent the remainder of that series. Okay, so in this case now, when we have Taylor series, the series is in form of x minus a. Okay, then where R, where the remainder now takes the form of R, this is the value of the remainder. That the value of the remainder will be f raised power n is not of a now, of x naught. X naught lies between a, close interval a and x. Okay, this x naught, which will be the remainder, lies in the range of close interval x, a and x. So let's take note. Under the series expansion of functions, we started with the Taylor series expansion. So Taylor series expansion is in form of x minus a. But the second one, we are going to give example on this, but before I go to the next one is when a is equal to 0. I'm talking about the next one. If a is equal to 0, when a is equal to 0 here, we are going to have the series in x. Then here we are going to have only x here. There won't be a there. A is equal to 0. That one is called Maclaurin series. That will be the second series that we are going to consider. So if you have a series in form of x, it's called the Maclaurin series. In case of Maclaurin series, f of x will now be f of a is equal to f of 0, f prime of 0, x, f prime of 0. A will become 0. When a is equal to 0, we use what is called Maclaurin series. It's no longer Taylor series expansion. Okay, that is Maclaurin series. So in this Taylor series expansion, this is what we are going to use. This is what we are going to have under Taylor series expansion. We make use of this expansion. So I'm going to give one example now to explain Taylor series expansion in details. So I'm giving one example now to explain this Taylor series expansion in details. But just take note that if you have a function, that function can be represented as a power series in form of x minus a. So that function, once that function can be expressed in terms of x minus a, then that function takes the form of Taylor series expansion. So let's take example under Taylor series expansion. Let's take example under Taylor series expansion. I'm going to give example now. Then we'll look at how we can actually obtain the expression. So example, let's say example 1 under Taylor series expansion. Under this Taylor series expansion, let's take example 1 under Taylor series expansion. You say obtain the expression in Taylor series. Which expression? Sine x. Okay, so we have to obtain the expression of sine x in Taylor series expansion. What do we do here? Of course, we know in Taylor series we know that f of x will be equal to sine x. No, this is a trigonometric function. F of x will be equal to sine x. We are going to find f prime of x. We go ahead and find f prime of x, f prime prime, f triple prime, up to maybe f raised power 6 prime of x. We can truncate it because it's a series. We can say plus dot dot dot. Okay. So if f of x is equal to sine x, then f prime of x will be equal to what? Cos x. We can also have f prime prime of x. If we differentiate cos, it will be equal to minus sine x. Then we can have f prime 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 of x. That will be equal to minus cos x. Then we have f for this will be equal to sine x. Then we can have f5 of x. That will be equal to cos x. Then we can have f6 of x. That will be equal to minus sine x. We might have to stop at that fixed value. We might have to stop at that fixed value. That's what we're going to get. Then we go ahead and look for this f of x. We now look for f of a, because that is what we have in the formula. F of a, the only difference is that whenever you see x here, we just change it to a. That's what you're going to have. This will be equal to sine a. Then f prime of a will be equal to cos a. Then f prime prime of a will be equal to minus sine a. F triple of a will be equal to minus cos a. Then f raised power 4 of a will be equal to sine a. F5 of a will be equal to cos a, while f6 of a will be equal to minus sine a. That's what we're going to get. So how do we obtain the Taylor series? How do we obtain the Taylor series here? Then for us to be able to obtain the Taylor series here, this is what we do. The Taylor series of this sine x down. The Taylor series of this sine x will not be, if we consider that formula, what are the Taylor series? We know that f of x is equal to f of a plus, that is, let me first write the formula. So we know f of a up to f6 of a, we know the value. So by Taylor series formula, f of x is equal to f of a plus f prime of a all over 1 factorial x minus a plus f prime prime of a all over 2 factorial x minus a squared plus dot dot dot. So in this case now, our f of x is sine x. So the Taylor series now will not be sine x, will not be equal to sine x, will not be equal to the first one. What is f of a? F of a is equal to sine a. We put sine a here. Sine a plus what is f prime? F prime of a. F prime of a is cos a. Is cos a. So f prime of a is going to be cos a here. Is cos a. So we are going to have x minus a all over cos a. 1 factorial is 1 plus f prime prime of a. F prime prime of a is minus sine a. That's minus sine a. We are going to have, then if you change this place to minus, we are going to have this to be minus x minus a squared sine a all over 2 factorial plus, after f prime, we are going to have f prime prime. F prime prime of a is minus cos a. So here we are going to have minus x minus a cube cos a all over 3 factorial, all over 3 factorial. Then what is f prime prime? Is a series, so we continue. Plus is plus x minus a raised power 4 all over 4 factorial. Then f4 of a will be sine a plus, we can start to truncate it. So since it is a series, we can start to truncate. When we truncate, we have this empty as we can start to rewrite the value of all these 4 factorial. This empty as sine a plus x minus a cos a minus x minus a all squared sine a all over 2 factorial is 2 minus x minus a cube cos a all over 3 times 2 is 6 times 6. So plus x minus a raised to power 4 sine a all over 4 times 6, 4 factorial will be 24 plus dot dot dot. So this will represent the Taylor series expansion. This will represent the Taylor series expansion of the problem. So let's take notes that under Taylor series expansion, that's what we are going to have. So Taylor series expansion is, we represent it in form of x minus a. That's what we are going to have. Okay, so that will represent the Taylor series expansion that we are going to have. That's the Taylor series expansion. That's the Taylor series expansion. So I will introduce the second expansion now, which is called the Maclaurin series. In case of Maclaurin series is the same thing as Taylor series expansion, but the only difference there is that under the Maclaurin series, the value of a is equal to 0. So the series will be of the form f of s will be f of 0 plus f prime of 0 x plus f prime prime. Okay, I'm going to write it. Let me try and write it. I will try and write it. So I think we can see this example. So let me try. I want to introduce Maclaurin series now. I want to introduce Maclaurin series. So in case of Maclaurin series, so this is the series expansion. This is the Taylor series expansion of sin x. We can find the Taylor series expansion of any function. We can find the Taylor series expansion of some of this function. As long as we can write the series in form of x minus a, then we'll be able to find the Taylor series expansion. So let's consider second expansion, which is called the Maclaurin series. So this is called the Maclaurin series. This is the second one. It's called the Maclaurin series. So what do we understand by this Maclaurin series? Of course, assuming that a given function can be represented by a power series in x. Note that under the Taylor series expansion, that function can be represented in form of x minus a. This is for Taylor series. But in Maclaurin series now, the value of a is equal to 0. Once value of a is equal to 0, we have only x. So under Maclaurin series, we are assuming that a given function can be represented by a power series in x. That series is necessarily of the form of Maclaurin series. That is, in this series now, our f of x will be equal to, instead of f of a, we are going to have f of 0 plus, we have f prime of 0 all over 1 factorial x plus f prime prime of 0 all over 2 factorial x squared plus f prime 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 of 0 all over 3 factorial s cubed plus dot 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 in that order. The difference between this Maclaurin series and Taylor series is that in case of Taylor series, the series can be expressed in form of x minus a. But under Maclaurin series, the value of a has become 0. So that's not just the difference. And if it is the Taylor series, we are going to have f of a. Then f of a, x minus a, f prime prime of a, x minus a all squared, and in that order. But under Maclaurin series, the value of a is equal to 0. So that's why we don't have anything in form of a when it comes to Maclaurin series. So I'm going to take one example. Let's take 1 or 2 examples under Maclaurin series so that we have an idea on how to express Maclaurin series. Under Maclaurin series, let's obtain the expression. So let's obtain the expression. So under Maclaurin series, I want us to obtain the expression. Obtain the expression. Let's obtain the expression in Maclaurin series. Obtain the expression in Maclaurin series. Which expression? Let's say the first one. We can pick 2 expressions. The first one, y is equal to sin x. The first one, y is equal to sin x, that is f of x is equal to sin x. Then the second one, where we have the second one, we can have it to be y is equal to sine x plus cos x. So it's very simple. Once we know what to do. Okay? So how do we represent this expression in Maclaurin series? Of course, we know that y solution, we start with the first one. We know that y is equal to f of x, which is the series expansion of the function, and this same thing as sine x. So f of x is equal to sine x. So f prime of x will now be equal to cos x. In this case now, we have f of 0. You know, in Maclaurin series, it is 0 that we have. So this will be equal to sine 0. What is sine 0? Sine 0 is equal to 0. Okay, we get the value. So f prime of 0, that will be cos 0, and cos 0 is 1. So we have f prime prime of x minus sine x. Then f prime prime of 0 minus sine 0, that will also be 0. Okay, then we have f prime 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 of x, that will be minus cos x. So f prime 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 of 0 will be minus cos 0, that will be minus 1. So we do that in that order. It's a series. We can start to truncate it at any point. We can have f4 of x, that will be differential of cos. Cos is minus 9, that will be sine x. Then f4 of 0 will be equal to 0 because sine is equal to 0. Then let's do the last one. Maybe f5 of x, that will be cos x. So f5 of 0 will be cos 0, and cos 0 is equal to 1. That's what we are going to get. We are going to get. So we now generate the series now. Once we get this, we are going to generate the series. So how do we generate the series? Under Maclaurin series, what do we do? That's what I'm about to write now. I'm going to solve this first one. Then you'll be asked to, well, if time permits, we can still do the second one. Or you just go and try the second one. Then we'll meet at the comment section. So under the Maclaurin series, f of x, which is given as sine x, will be equal to, under Maclaurin series, this will be equal to f of 0 plus f prime of 0 over 1 factorial x plus f prime prime of 0 over 2 factorial x squared plus f prime 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 of 0 over 3 factorial x cubed plus in that order. So when we now have f of x to be equal to sine x, what do we get? When we have f of x to be equal to sine x, that is this question. What is f of 0? Our f of 0 is 0. So here I'm going to get 0 plus f prime of 0. F prime of 0 is 1. F prime of 0 is 1. So I'm going to get it to be f prime of 0 is 1. I want it to be 1. 1 divided by 1, of course, times x plus f prime prime of 0 is 0. Everything here will vanish. If that one is 0, then everything there will vanish. So we don't need to stress ourselves. This is 0. We have 0 over 2 factorial x squared plus when we have f prime prime of 0, f prime prime of 0 is minus 1. So I'm going to have here to be minus 1 over 3 factorial x cubed plus f4 of 0 is 0. So I'm going to have 0 over 4 factorial x squared plus f5 of 0 is 1. So I'm going to have 1 all over 5 factorial x raised by 5 plus dot dot dot. That's what we have. That's what we are going to get. So at the end of the day, the series that we are going to get will be of this form. Of course, this 0 is will be x. Here will also be 0 because 0 multiplied by everything will vanish here. Followed by plus times minus x cubed all over 3 factorial. Then this one will also vanish because 0 will cancel it. Then plus x raised by 5 all over 5 factorial plus dot dot dot. So this will be the Maclaurin series for sin x. That will be series expansion when we apply Maclaurin series. That is what we are going to get. Okay, that's what we are going to get. Then this will be for all. It will be for all values. It will be for all values of x. So we decide to truncate it. We stop it. You know, it's a series. We can try to. This is the first 6 now. We truncate it. That's the meaning of what we have done. So we can try to truncate it. It's allowed. We can do that for all values of x. So we have gotten the Maclaurin series for sin x. So how do we get the Maclaurin series for the second one where we have y? How do we get the Maclaurin series for the second one? For the second question, where we have y is equal to sine x plus cos x. That's what I'm about to do before we close the lecture. Of course, let me just write it there. We say y, the second one, y is equal to sine x plus cos x. Of course, what is y? F. Y is what? F of x. So y is equal to f of x. So f of x is equal to sine x plus cos x. So if you have it here, then we are going to do for f of 0. But when we get here, f of x is equal to sine x. Then f prime of x will give us, when we differentiate sine, we are going to get cos x. When we differentiate cos, it's minus sine x. That's what we are going to get. Okay? If we do that, that's what we are going to get. Then you substitute. Sine 0 is 0. Cos 0 is 1. So we are going to have 1 here. Sine 0 is 0. Cos 0 is 1. Then f prime of 0. So here, cos 0 will be equal to 1. Cos 0 here will be equal to 1. Then sine 0 is minus 1. So f of 0 there. F of 0 there will also be 1. F of 0 here will also be 1. F prime of 0 will also be 1. Then f prime of x will be cos 0. When we differentiate cos, it's minus sine x. Sine 0, sine x is equal to cos. That will be minus cos x. So f prime of 0, when this is sine is 0, here will be minus 1. So if you continue in that order, what are we going to get? Let me just stop at this one. F prime of x. When I differentiate sine, is cos. So I'll get minus cos. When I differentiate cos, is sine. That's cos is minus sine. Minus plus sine x. Then if I substitute here, f prime of 0, this minus 1 plus 0, that'll be minus 1. That's what I'm going to get there. So with this now, I can generate the Taylor series expansion. That is, in this case now, the Taylor series expansion will just be this. So the Taylor series expansion here, that is the function f of x here, will be sine x plus cos x. This is going to give us f of 0 is 1. So I'm going to have 1 plus f prime of 0 is 1. I'm going to have x here. Then f prime of 0 is minus 1. I'm going to have plus minus 1 over 2 factorial s squared here. Plus f prime of 0 is minus 1. I will have minus 1 over 3 factorial s cubed plus dot. If I expand this, what am I going to get? That will be 1 plus x. Plus times minus is minus s squared all over 2 factorial plus times minus s cubed all over 3 factorial plus dot. Of course, if we like, we can stop at this point. Then we must indicate that this will continue. When we truncate, it simply means that and so on. Then we are going to generalize that for all. This will be for all values. For all values of x. So that is how to expand using Maclaurin series. So if you have any question or you want me to explain further, just write at the comment section. I promise to attend to all the comments. Okay, I promise to attend to all the comments. But I want to do a recap because before I call it a day, that if you have a series expansion in form of x minus a, this is Taylor series expansion. But once a becomes 0, then we have that series expansion in the form of x. It is called Maclaurin's expansion. So this is the difference between Taylor series expansion and Maclaurin expansion. Thank you.